Hello folks, and welcome back to your own channel. In this series of 4 videos, we are going to cover end-to-end exploratory data analysis problem using Python and Tableau. This will give you comprehensive outlook for any data analysis problem that you might have. And guess what? In this video, unlike other videos, we are not going to use any readily available data set. Rather, we will curate our own data set. We are going to use API calls to get our data live from the World Bank website. And we will use Python to cure and analyze this data set and Tableau to create amazing visualization out of this data. So before we begin, if you are new to the channel, please subscribe to the channel. It's very important. As high as 60% of the people watching the videos to my channel are non-subscribers, so please do that. It's a small effort from your end but gives immense motivation to me. So hit that like button as well. Also, if you want to learn Python fully, please watch my Python for Beginners series videos. This will be 6 videos in all, and you will find link for those videos on your screen. Okay, let's begin. Have a look at today's session in a quickie fast forward. There you go. Awesome. So first and foremost, step number 1, let's define the problem. At broader level, we wanted to analyze the economic and social data of countries in G20 group. Now, with this objective, it's more exploratory analysis of data, but we need to define the parameters to be taken into consideration for this analysis. For your ease, I have outlined 16 unique and yet broad parameters for us to analyze this G20 countries. Now, you can add more parameters or remove certain parameters based on your own problem. But before we go to Python and start working, we need to understand what is API. An API or application programming interface is a set of rules that allow two pieces of software to communicate with each other. In other words, it's a way of one program to access the data or functionality from other. Now, the World Bank has an API that allows developers or analysts like us to receive data from various topics such as economics, finance, and redevelopment. To get started, simply go to the World Bank's API website to create an account and to get your API key. Once you have your API key, you can use to make a request to the World Bank's API and retrieve data in various formats, such as JSON or XML or any other format. Okay, so let's start. So we are on our Python notebook of end-to-end analysis, data analysis. Okay, so for this problem, we are importing couple of libraries here. And first and foremost, we are going to import library Pandas. So we'll call import Pandas as PD. Import NumPy as NP. Also going to import matplotlib and pyplot specifically from matplotlib. Also going to import cbon. Now these are standard 4 libraries which we are going to use throughout our project. Apart from that, we are also going to import WB data. Now, remember I talked about the API just now. We are going to do it in more simplified way because many of you are not aware how to do web scraping and how to actually use API keys to get your data. So there is an easy method out here. We are going to call World Bank data. That's a library, standard library available in Python. Now this library is API based. So whenever we use this library, it's actually going to hit the World Bank servers and get the data from the World Bank website. So to do that, you need to first install World Bank data library. And for that, you need to type this in your Jupyter cell, pip install WB data. Now, on my computer, I already have this library installed. So you just need to run this cell and this library gets installed in your computer. So I'll just comment out this cell for us. And after you install this library, you need to import it to this workbook. So I'll call import WB data and run the cell. I'll add a couple of cells down below for us. Now, all our libraries are imported. So first thing, we need to create our own data set, right? So how do we create our own data set? We have defined 16 unique parameter, which you can see on your screen now. Now, like you take a first parameter, let's say gross domestic product or GDP in other words. So we need to go and search whether such parameter is available with World Bank or not. Okay, so let's call our library WB data. And from it, we are going to use different methods. So the methods which we are going to use first is search indicators. Now, to track the 16 parameters that we want data from World Bank. So first parameter, as you see on your screen, the GDP or the gross domestic product. Let's search for it in World Bank database. So we'll type GDP and this will return us all the indicators that contains this string GDP. Let me execute this. Okay, it has given all the indicators and there is a host of indicators. So we can do quickie search. What we are interested is to receive GDP in terms of dollar value, US dollar value. Let's quickly search. What do we have here? So there are a host of parameters which is available. And there you go. We can see this. Now this is the parameter we are interested in. And this is the ID of that parameter. And this is the name of the parameter. What we are interested is to get this ID as well as this name. Now, with this help of this ID, we are going to fetch the data. Now, we can do this manual search or we can again search through automation and we can find out all the parameters that we want. But since we have only 16 parameters, I have manually tracked all the IDs and the name of these parameters and listed down in terms of dictionary for you. And let me show it on your screen. So these are all the 16 parameters which I have saved under dictionary indicators. The dictionary as part of your indicator names. So you have all the indicator names here with all the 16 parameters that we have and their unique ID from the database that we searched just now. Let me execute this and this will give me the dictionary values of it. Now, I wanted to convert this dictionary into data frame, nice data frame where I can see and call as and when it's required. So let me convert this dictionary to the data frame and let me say pd dot data frame and let me put this indicators dictionary there. As we execute this, it has converted successfully to the data frame and this is how we call indicators to view this data frame. As you can see, we have all the 16 starts from 0 to 15. So all 16 indicators name and their unique indicator ID. Now we are going to use this indicator ID and to hit to the World Bank database through WB data library and through API calls and to receive the data of selected countries for selected years. Now, as I said, we want data only for selected years. So year for consideration, I took from year 2015 to 2020 because I've seen this data and this data is not updated for a couple of parameters. For some parameter, data is available till 2021. For some parameters, the data is only available up to 2020. So we'll take the analysis period from 2015 to 2020. And for that, we need to define our start date and end date. For that, let's import this library, date time. As we do that, this is imported date time library. With the help of this, we can play around the different dates and time in the Python when we have that data type, right? And let's call our start date as 2015 year. date January, 1st January 2015. That's our start date. Let's similarly call our end date. And end date is 31st December 2020. Now this date is a string format, so we need to convert it into the date time format. Let's call this object start date under object, and we'll call date time library, and from date time library we are going to call string p time, strp time, and we are going to pass this start date, right? And we also define the format %y. That means we want year first in 4-digit, and that's why capital Y in terms of percentage. Then we want hyphen, again percentage, month in 2-digit, again hyphen, percentage, and then day. So this is the format of our date and time. Similarly, we gonna create the end date object, and we're passing end date here, and again we require the same format. Once we have this format, we're going to create our data date as a tuple object required, and where we pass this start date object as a start date and end date object as end date, right? Let's execute this cell. As we do that, we can see data underscore date is a tuple, right, which is having this start date. Now this is not very user friendly to read it. So what it has essentially done, it has taken the string and converted into date time format, right? So this is what we are going to use as our period of analysis when we try and import data from the World Bank website. Now let's define this data frame called new data frame, new df, and which will be nothing but blank data frame, pd.data frame, right? Now let's see how we can call the data from WB data library using API call. So let's call WB data, and from this library we are going to use get data method, and here we pass on our maybe first indicator, let's say gross domestic product, and let's copy the indicator ID for time being manually. Let's pass it on as a string. Here we also want data for all countries for now. So let's pass country is equal to all. We also wanted data for specific period, else it will be very huge data. So we say data date is equal to data date. That's we defined our period previously. And let's try and execute this cell. Now we get this data in weird format. Now this is not the format which we want. We want our data to be maybe in slightly more readable format, maybe pandas data frame. So there is an argument called pandas here, and we can pass pandas is equal to true. Once we do that, we get this data in nicely neat out pandas data frame format, and we can store this data into maybe pandas data frame, right? So if we do something like this, pd.data frame and pass this value and execute this, we'll get this data in this data frame, and this value is nothing but gross domestic product for each country and for the required year. So this is what we want, but this is just one indicator. We want all 16 indicators. So how do we do it? We run this particular cell and we append each of the value that we receive adjacent to each other, and we create a large data frame containing all 16 parameters value. So let's try and do it. For that, we need to run in loop. And how do we do it? So we required all the indicator IDs, right? So this is our indicator data frame, right? And from this data frame, I want indicator ID. So I can call indicator ID, and this will give me all the indicator ID as a list. Now I can use for loop. I can say for I in indicator ID. That means I am running through each of the indicator ID. And for instance, when in the first iteration, the value of I is ny.gdp.mktp.cd. In the next iteration, it will take value this, and so on for for all the 16 indicators. Now, for each iteration, I wanted to create this data. So what I'm going to do is I'm going to store this particular data into new data frame that we just created as a blank data frame. So I'm calling new underscore df, which will be nothing but this part, right? So this part. Now here, I do not want the static indicator because we are running over loop. So instead of this indicator, we are passing indicator is equal to I, and that will take value, dynamic value of each indicator every time. Want countries is equal to all. That's correct. Pandas is equal to true. Data date is our period. That's what we wanted. And this will create new underscore df. Now this new underscore df is still not data frame. So we need to convert into data frame. So we call it pd dot data frame, right? And we'll pass it on this new data frame here to create as a data frame. And we are also resetting our index here. It's required because we are merging this data frame in iteration. So if we don't reset our index, we'll not get one large data frame as we required, and it will give you a weird kind of error. So it's important for you to do reset index here. And as we do reset index, it will create a new index every time for us for this data frame. Once we do that, let's also define our column, because as we see, once we get the data, we do not get the intended column name here. So here we receive the column name as date, and here we receive column name as value, while the column name should appear as maybe GDP. That's the name of the indicator. So let's try and correct it here. So we call new underscore df dot columns, and we define here columns as first column we always wanted is country, and then the next column which will appear for all the indicators is year, and the third column will be very specific to this ID and basically the indicator name. So what we are going to do here, let me take a step back here and let me try and show you. So indicators, I'm going to call indicator name, right? And this is what we want, right? But we want it against the specific ID, indicator ID is in subject. So we'll call wherever indicator ID is a specific ID. So let's say in I is in our case, right? So we'll use this as a filter and we'll call indicators and use this indicator ID, right? And give me the indicator name. Once we have matching indicator ID, give me the indicator name. And from this indicator name, I also want values, right? And values in the sense, I just wanted the name of that particular ID and really do not want index. So that's why I put 0 here. Now let me show you, instead of I, let me take any random ID. So let's take the first indicator ID and let me show you how does this code work. So instead of I, if I put this, what it essentially means, and let me put it under string format. So when I pass this, what I'm basically asking out of this code is use this ID, and whenever this ID is matching, give me the column name matching to this ID. So let me execute this. It's going to give me this, right? If I don't pass values, it's going to give me this kind of index and the value. So from this, I only want values. I really don't want index. So that's why I passed on this value, and I want 0th value, and that gives me this gross domestic product, right? So I'm going to use this particular code, and let me copy this and paste it here, and that will be my third column, right? Now here, I want dynamic column name, column ID. So that's why I'm passing I here. So once I do that, that will define my column name. So now this new data frame, every time it will take new indicator and create new DF. So I wanted to append this new df into our final df. So let's do df. Let's define df is equal to pd.concat, and I'm going to concat every time. And this is our df and new df. And we're going to concat it adjacent to each other. So we are passing x is equal to 1. Before this, it's important to define df. So again, let's take a step back and define df as a blank data frame, pd.data frame here, and let's execute this. So now df is defined. So every time it will take new df and it will concat with df. So essentially it will take first indicator, get the data, put it into data frame, take the next indicator, get the data, attach it to the previous indicator's data, and that is practically storing in our df. So once it iterates through all the loop, the df will have the 16 parameters data. So let's execute this. As we do that, right, the cell get executed, and let me add few more cells, and let's see what do we have in our df now. So as we do df.head, we can see we have all the data. So we have 5 rows because we are seeing head, and 48 columns. Since we have 16 indicators and 3 columns across each indicator, that gives us 48 columns. Now, if you see country and year, this column is same across all the indicators. And we practically want only one country and 1 year column. So rest of the columns are repetitive in nature, and we should drop that columns. So here it's a little tricky because the column names are same across the data frame. So we need to do it more carefully. Okay, so let's call df1, and this will be the copy of our original data frame, df. And from df1, we are going to drop 2 columns, that's country and year, right? And since it's a column, we are passing x is equal to 1, right? And let's save it this again as a df_1 to maintain the changes. As we do that, let's see the df_1. As we do that, we can see that all the country and year is dropped off. But here's the problem. We have dropped country and year, but we still want one country and 1 year as a column to be appear here, right? So we need to again concat it. We practically cannot retain because the column names are same. So we have to drop all the columns. Now we are again using this only 2 columns to add back here. And this is how we do it. So let's call our df1 again. So let's say df1, right? And we say that df1 is nothing but pd.concat, and we are concating 2 data frames here, right? So if we say our original df, right? And in our original df, if we call iloc, and let's say we call all rows here, and we only wanted column which is first to column in our original data frame, that's country and year. So it's my 0th column and it's my first column. So I can call 0th column all the way to 2nd column, but 2nd is excluded. So column number 1, 0 and 1. So this will give me country and year practically. So I'm going to use this piece of code here, and I'm going to concat this particular data frame with my new data frame, so df1. So let me type this. So this is my first data frame. This is my first 2 columns, and the next column, subsequent columns will be nothing but my new data frame, that's df1. Since I'm concatenating adjacent to each other, I'm passing x is equal to 1. As I do that, this is my new df1. And let me show you now, our new df1 looks like this, which is practically having country, year, and all the other 16 columns that we have, right? So this is our data set, but this data set contains all the countries. Now remember, our problem is very specific. We only wanted countries which are pertaining to G20, right? If you don't know what is G20, you can Google it out. It's a group of 20 countries for economic and other social cooperation, which has been formed. For our simplicity, I have noted down all the 20 countries from the website and store it as a list here. So let's say countries is equal to, so these are the 20 countries that we have. I'll store it as a list and let me execute this. So this is our countries of interest. For that, the data which we have right now, it's for all the countries. Now we don't want data for all the countries, but we only want data for this 20 countries. So let's filter our data for this 20 countries only. Let's call new data frame DFF here, and DFF is nothing but our df_1, and from this data frame, we wanted to have df_1 wherever country is in country. So what it essentially does is, so from our df1 data frame, it takes country column, and for each row, it will check whether that row, the country name, is belonging into this list of 20 countries. If it is there, it will only filter the records which satisfy this condition and store it as our new data from DFF. So it will iterate over every row and it will check the country name for that row is in the list of this 20 countries. If it is there, it's gonna append that row. If not, it's gonna omit that row. Let's execute this cell, and that's filtered our data. So when we see DFF and head, we see that now, which will have the countries very specific to our 20 countries in consideration. Let's see DFF.shape. So we have 102 rows across 18 columns. Now, if you still see the DFF index, it is still our, although it's 102 rows, but if you see the index, it still maintains the original index. So we need to drop this index. So we'll do dff.reset index and we'll drop the original. So we'll type drop is equal to true, and we'll also type in plus is equal to true to retain the changes. And now if we see our DFF data, that will contain all the data of 20 countries, and that's 102 rows across 18 columns. Okay, so we have successfully fetched our data across the 16 indicators that we wanted, and for the year into consideration from 2015 to 2020 for the 20 countries that we intend to analyze. Now this dataset, we are going to use it and further analyze each of the parameter in detail and doing lot of analysis in Python before we visualize this analysis on Tableau. I'm stopping here now. For you to run this code on your computer, you can use more parameters if you wish to and try and run this codes and create your own data set. I'll meet you in my next video where we are going to analyze this data set further. Thank you so much for watching. Bye-bye for now. Please like, share and subscribe my channel. Thanks for watching. Bye-bye.